Good day, everyone. Welcome to the part 1C of our sword. By the way, this is Gifted Brain, aka Saizu, first in Africa, sixth in the world. If you enjoy our work, please do well to subscribe to our YouTube channel and then keep your notification button on so that you will be notified when we drop new tutorial videos. Again, today we shall be considering conjugates of sword. Actually, you see, two swords are said to be conjugates of another if their product gives rise to a rational number. For instance, let me illustrate now. You see, conjugate of root 2 plus root 3. Conjugate of this sword actually is root 2 minus root 3. And you know why? Because the product of these two swords, this first and second sword, will give me a rational number. What I mean is this: take root 2 for instance plus root 3 and find their product. Obviously, you know, this will give us, first of all, use this to multiply this. That is root 2 times root 2. This will give me root 4, which is 2. Or root 2 times root 2, like I said in my rule, this will give me 2. Now let's take root 2 to multiply minus root 3. Right there we have minus root 6. Again, let's take now root 3 to multiply root 2. Yes, here we have plus root 6. And lastly, let's use root 3 to multiply minus root 3. Right there we have minus 3 because root 3 times root 3 is 3. So we have minus 3. Then plus and minus will give us the minus we are talking about. Now look at this. We have minus root 6 and plus root 6. So they eliminate one another. And we'll be left with 2 minus 3. These 2 here and the minus 3 here. And that gives us minus 1. You see that we now have a rational number the same way it is. So often if I ask you what is the conjugate of root a minus root b, for instance, the conjugate of this is root a plus root b. It's as simple as that. Whatever when multiplied with that sword, we make it a rational number is the conjugate. So on and on. Let's take an example under this now. This example 1 says find the conjugate of the following sword: root 3 minus root 2. Well, quite easily done. The conjugate of root 3 minus root 2 is root 3 plus root 2. And you can try that if you multiply these two numbers, what you would have. Again, for the second one, root 3 plus 1. What is its conjugate? The conjugate is root 3 minus 1. And lastly, second one, the third one now, root 6 minus 2. What is the conjugate? The conjugate is root 6 plus 2. So quite easily done. And now we can see how we multiply this. This question say simplify by rationalization. The first thing I want to say is that, we have a is 1 over root 2. The first thing I want to say is that, why rationalization actually? Why do we talk about rationalization of the conjugate of a sword first of all before I solve this question? Now look at this question. And this is a fraction and it's 1 over root 2. Obviously, even if I tell you that root 2 is actually 1.414, for instance, and I ask you to put that here, you know, you will say this is 1 over 1.414. But if you have to divide this with the use of your hands, it will be more difficult because, well, 1.4 cannot go in 1, but if you go on to try to divide it, even if you write at 0 points and you put 0 here, at the same time it's still difficult to know how many times 1.414 will go in 10. That's because the denominator is a root or is in decimal. But when you rationalize, for instance now, like let's solve this question. To do this is to rationalize the denominator. We solve by rationalizing the denominator. So all you just need to do is that 1 over root 2. Now, as we have roots at the denominator, all I just need to do is to say this is multiply the numerator and denominator by the conjugate of the denominator. Conjugate of root 2 is root 2. Why is conjugate of root 2 root 2? Because if I multiply root 2 by root 2, I will have a whole number. Yes, root 2 can have other conjugates actually, like conjugate of root 2, for example, you can say it's root 8, because when you multiply root 2 by root 8, you still have another whole number as your answer, but that will give us root 16. But I don't want to talk about that. So let's take the basic one. Conjugate of root 2 is simply root 2. And then you can see that this can be expressed as what now? Root 2 over 2, because root 2 times 2 is 2. But now, how does this make sense, or how can we apply into what I was illustrating before? If 1 over root 2 can be expressed as root 2, I think that is better for us. The reason is because if I tell you that root 2 is 1.414, you can easily make the division now, because the decimal is at the numerator, and that will give you 0.707. That's what we're talking about. What I'm trying to bring out in all of this is that in mathematics, it is better that the numerator is a surd or decimal than that the denominator is a surd or decimal. That's the idea that born this conjugate of a surd thing, so that we can remove surd from the denominator. So that's about that. Now let's take the number 2 question. Actually, number 2, you see number 2 is saying 1 over root 2 minus 5, and obviously the denominator is a surd, so I must remove that surd from the denominator, and we can do that by rationalizing the denominator. Again, what is the conjugate of the denominator? The conjugate is root 2 plus root 5. So I will multiply numerator and denominator by that. And so, sorry, not times, plus. I will multiply the denominator and numerator by root 2 plus root 5 over root 2 plus root 5. Obviously, this will give us 1 times everything at the numerator will give us root 2 plus root 5. But root 5, not root 3. Root 5. All over. Again, at the denominator, we have root 2 multiply root 2 will give us 2. And then root 5 multiply minus root 5 multiply root 5 will give us minus 5. Please, I didn't do the complete multiplication. Why? Because when 2 conjugates multiply, I've not said that before, but take note. When 2 conjugates multiply, just multiply the first by the first and second by the second, and you get your answer. So easy than trying to do everything. No, if I'm going to do all of this, it will be root 2 times root 2. That will give me 2. And again, root 2 again times root 5. That will give me plus root 10. And then again, minus root 5 times 2 minus root 2. That will give me minus root 10. And then root 5 times root 5. That will give me plus 5. At the end of the day, the middle 10 will cancel out. So I easily just take the first and the last. So this is just simply root 2 plus root 5 all over minus 3, and that is our answer. Or you can express as minus 1 over 3 of root 2 plus root 5. So this is what we're talking about. You can take the C now. Before the C, I want to say that if simply we are given what our root 2 and root 5 is easier to get the answer, because they are now at the numerator and not denominator. So this is the C. If you carefully do it, this is what you would have, and it's simply still done by rationalizing the denominator. Let's take another example now. And look at this example 3. Express 8 minus 3 root 6 all over 2 root 3 plus 3 root 2 in the form of m root 3 plus n root 2, where m and n are rational numbers. To solve this, we also apply the technique of rationalization, and that will be 8 minus root 3 now, right at the question. As we look at this question now, the first thing to do, like I said, is to rationalize by the conjugate of the denominator. And then we've done that already. Multiply by 2 root 3 minus 3 root 2, because the conjugate is 2 root 3 minus 3 root 2. So I multiply the denominator and numerator by that same value or that same conjugate. And now let's do the multiplication. 8 times 2 root 3 will give me 16 root 3. Again, 8 times minus 3 root 2 will give me minus 24 root 2. I've used this, the 8, to multiply this. Again, I'm using the 8 to multiply the minus 3 root 2. Then I will now use the minus 3 root 6 now to multiply. If I'm doing that, I will have minus 3 root 6 times 2 root 3. That will give me minus 6 root 18. And then minus 3 root 6 times minus 3 root 2. That will give us plus 9 root 12. Again, all over at the denominator. I don't need to take these processes one after the other. I will just say the first multiplied by the first. That will give me 4 times 3, because root 3 is root 3 times root 3 is 3. Then minus root 3 times root 3 root 2 times minus 3 root 2. That will simply give me 9 times 4. 9 times 2, sorry. So this is what we have. So let's go to simplify the numerator. This is 16 root 3 minus 24 root 2. But you see this 6 root 18 is not the root 18 is not in its basic form. In its basic form, it can be expressed as root 9 times 2. Root 9 times 2. And then the root 12 is not in its basic form. It can be expressed at root 4 times 3. We've done basic form earlier. And then this will be all over 12 minus 18. Then we can proceed further now to say that this easily can give us 16 root 3 minus 24 root 2 minus 6. That 9 times 2 will just simply give us 3 root 2, because 3 root 2, please take note. And then plus 4 times 3 will simply give us, root 4 times 3 will simply give us, sorry, let me correct that, so that will simply give us 2 root 3 all over minus 6 now. So all over minus 6. And then we can now simplify. So this is giving us 16 root 3 now minus, okay, plus 18 root 3. How did I get this? It's as a result of 9, the 9 here multiplied by the 2 root 3. That will give me 18. So I will now write again minus 24 root 2, 24 root 2, then minus 18 root 2 as well. The next question is, how did I get my minus 18 root 2? It is this 3, this minus 6 multiplying this root 3 root 2. That will give me minus 18. Then, you know, all over 6, all over minus 6. And then this can be written as 34 root 3 minus, okay, minus all over minus 42 root 3. And then you can as well say that this can now be expressed as 34 root 3 over minus 6, then minus 42 root 2 again over minus 6. This will easily give us, this is 17 over 3 minus 17 over 3 root 3, and then plus, because minus in minus give me plus, then 6 in 42 will give me 6, it give me 7, sorry, so 7 root 2. So this is our final answer. Now in this case, now I could have also asked in the question, this is our final answer, I can also ask what is the value of m and n. You know, m is associated with root 3, so you can compare what's associated with root 3 in our answer is minus 17 over root 3. Then you see n here is the coefficient of root 2, or is associated with root 2. Again, what will that value be here? The answer is 7, the number beside the root 2. So that's that about that, because I would have said find the value of m and n. So that's that. Let's take the last example here. Now take a look at this example 4. You can as well pause the video and then try on your own. But when you do this question, to solve the question itself is to rationalize by denominator as usual. So try rationalizing on your own. If you rationalize, you get what we have here now. So this is what your result will look like. And then we can proceed further now from here. So what we just simply need to do is to express some of the surd in their basic form. So if you express in its basic form, we would have the minus 6 root 50 to be expressed as root of 25 multiplied by 2. And then minus the root 20 can be expressed as 4 times 5. Yes, 4 times 5. Then all over 45 minus 2. And so we can have this as 15 root 5 minus 5 root 2 minus 6 into the bracket of 5 root 2, and then minus 2 into the bracket of 2 root 5 all over 43. And so again, it can be further expressed as 15 root 5 minus 5 root 2 minus 30 root 2 minus 4. Sorry, a little mistake. This should have been plus. Sorry, plus, plus, plus. And then here too, this should be plus. So it's a mistake. When you multiply the last, that is gotten by multiplying this by this is a plus actually. So it's a mistake. So 4 root 5 over 43. And so finally, if we proceed, we have our answer to be. So this is what our answer will look like. But the question says we should express we should find express in form of m root 2. This is it, m root 2. That's what the question said. And n root 5. And then let's get the value of m and n. By comparison, we can see that m root 2 is same as minus 35 or equivalent to 35 over 43 root 2. So by comparison, we can say our m is equal to minus 35 over 43. That's as simple as that. And then our n root 5 is equivalent to 19 over 43 root 5. And then we can see root 5. We can see that our n is equal to 19 over 43 when we compare. So that's that about that. You can try the following exercises now. Don't forget to subscribe and then on your notification button. Thank you and God bless you.